Hey guys, welcome to Calculus Daily, episode 10. We're looking at one achieved question and two merit questions. The two merits are on differentiation and integration. Okay, so first off, this question is asking you to find out A and B are rational numbers. So conjugate multiplied by conjugate. You got 2 plus root 5 and 2 plus root 5 in the denominator. So what do we've got? We've got 8 plus root 4 root 5. No, hang on, let me write that again. Because 8 plus 4 root 5, and that's divided by the bottom two numbers multiplied by itself. So I'm going to get 4, 8.
Even the top isn't minus?
Where? 4 times 2, 8.
Yeah.
Yep, so I have 8 plus 4 root 5 divided by negative 1, which equals negative 8 minus 4 root 5. Therefore, A is equal to negative 8, B is equal to negative 4. Questions? We all right with this? Can we go on? Next question. This was an achieved question. Okay, next. This one is asking you, for what values of k does the function have a stationary point at x equals negative 1? Oh, okay. So first off, what does stationary point mean? Yes, so in other words of describing it, what's the gradient? 0. So we're actually looking for f dash of x equals to 0, but because they actually tell you it has a stationary point at negative 1, so we know that f dash of negative 1 equals to 0. Now, we've got to differentiate f of x first to actually figure out what f dash of x is. So we got x minus e to the power of x minus k, and I'm going to bring the x to the numerator, so I can write it as x to the power of negative 1. Once I do that, I can start differentiating it. So I have f dash of x equals 1. Ex, when you differentiate it, it's just going to be e of x minus k times negative 1 x to the power of negative 2. Is that all right? So this could be written as 1 minus e to the power of x minus k over x, plus k over x squared, because I've got two negatives there. So this is all I have at the moment. Now what it says is I've got f dash of negative 1 equals to 0. So I could actually substitute. So if I write f dash of negative 1 equals to 0, then I can say 0 equals 1 minus e to the power of negative 1, okay, plus k over negative 1 squared. All right, so basically we always get interruptions from certain guests, but that's okay, we'll continue. What was I up to? Something, subbing. All right, done. So got 0 equals 1 minus e to the power of negative 1 plus k. So if I was to rearrange it, I would get k equals 1 plus e to the power of negative 1, or negative 1 plus e to the power of negative 1. All right, let me just check what is achieved and what is merit. Hold on, Okay guys, you can actually leave your answer in this format, so this gets you a merit. All right, or you could leave for achieved. You're looking at this part just for the f dash. All right, that's why I'm telling you it's pretty much impossible to fail differentiation. Okay, that was a merit question. It's just knowing what to use at what points. Is that all right? Next question. So obviously the first step you really want to do is you want to be able to integrate that. Now looking at this, one of the things I'm going to tell you guys again and again, look at what's in the denominator and look at what's in the numerator. If you find that the numerator is actually a differentiation of the denominator, then you could actually have, I think it looks like this. One of the theories that we talked about was when you have f dash of x, f of x dx, we can write this as ln of f of x plus c. Do you guys remember this? We should. We've done this. So in here, you can kind of see that the denominator is x squared plus 5x. If I differentiate x squared plus 5x, I actually get 2x plus 5. So I can straight away put this equation here, because I've got f dash of x in the numerator and I've got f dash of x in the denominator. I can write this straight away as ln of x squared plus 5x. And then this part here is between 2m and m. Okay? What it also tells you that this equals ln of 3. So I can put ln of 3. And now I just need to figure out what the value for m is. And I think for integration, this part right here gets you an achieved. I know that for sure. Definite integrals, we don't need to worry about c. So whenever you have like these things there, you don't really need to worry about c, because you know how you substitute and then subtract it from the other one? So the c's kind of get eliminated, so we don't have to worry about the c in this case. So from here, it's just a matter of rearranging everything and putting things in perspective. So I have ln of 3. I'm going to do the first bracket with 2m. So I have ln of 2m squared plus 5 times 2m. That's subtracted by ln of m squared plus 5m. Is that okay so far? Okay, so just expanding and simplifying things here. I've got ln of 3 equals ln of 4m squared plus 10m minus ln of m squared plus 5m. Does that look alright so far? Okay. I can simplify this because see how when you have two ln's, if you have ln, how do I got it? Just remember, if I had ln of a minus ln of b, I could write this as ln of a over b. Do you guys remember that? So this equation, I can rewrite this as ln of 3 equals ln of 4m squared plus 10m divided by m squared plus 5m. Okay? Now I can eliminate the natural logs because it's natural logs on both sides. I can get rid of the ln's and all I have is 3 equals 4m squared plus 10m divided by m squared plus 5m. Is that okay? What I've done there, folks? Anna?
Yeah.
Okay. So now what I can say is, because I'm just saying that whatever's inside this, the 3 has to be this whole thing here. All right, so rearranging this, I've got 3 times m squared plus 5m equals 4m squared plus 10m. So expanding, simplify, and I should end up, that's 15m, 4m squared plus 10m. So 0 equals m squared minus 5m. Therefore, I can write this as m minus 5. So m is equal to 0 or 5. But I can't really have m equals to 0. I have to leave m as 5. Okay? And I think that's what gets you a merit. So it's not that bad. It's just, I mean, like considering the amount of work you need to go from your achieved to basically going to a merit. It looks lots, but it's just algebra, just rearranging things. That's all it is. Questions about this one? Cool. That's it for this session. And Kunj has gone to sleep. Oh, he's awake. Hey, welcome back, Kunj. All right, we'll see you guys. You can catch us up online, Kunj. All right. See you guys.